Hi, and welcome back to the Save It for Parts channel. I discuss a lot of satellite-related topics on this channel, but one thing I haven't covered yet, which is frequently requested in the comments, are so-called zombie satellites. Now, these are satellites or spacecraft that have failed, malfunctioned, or are otherwise considered dead in orbit. Maybe they were shut down on purpose by the original operators, maybe they malfunctioned, and maybe, just maybe, in a small number of cases, over time the malfunction fixes itself, or some other malfunction happens that makes the satellite start operating again unexpectedly. Now, this has happened with a couple of satellites that I don't know a whole lot about. People often say that I'm an expert at satellite topics, and I'm actually not. As I've said in many videos, I am not an expert. I am just an enthusiastic amateur who knows a little bit about a variety of space topics. And when I want to learn more about a particular space topic or find out something that I am not an expert in, I call an expert. So let's see if we can call up Scott Tilley. He's an expert on the zombie satellite topic. He's found a number of these lost or forgotten satellites himself. So let's give Scott a call on the old interstellar communications orb here. Okay, I think that was the wrong Zoom meeting. Let's try that again. Oh, yeah, I gotcha. I've got you up on the sphere too, which is probably unnecessary. After I set this all up, I realized I could have just recorded you and then put you on the sphere. And yeah, sorry about that. I was thinking about it. I was like, yeah, it'd be fun to get him on the sphere, and then you know, I'll have a little gimmick where I have you watch Stargate SG-1.
Actually, I used to work on the movie set.
Oh, you did? Oh my God.
I'm the guy that built the flashy blinky units.
All right, we had some Zoom issues and some globe issues, so I'm not going to do the whole thing on the projector globe. We'll just do a regular Zoom recording for most of this.
Hey, hi, I'm Scott Tilley. You might know me as the guy that finds zombie satellites from time to time. Recovered image back in 2018, a lost NASA satellite. And later, I've recovered a number of zombie satellites in Earth orbit. And I've also taken an interest in lunar space and keeping track of mostly undocumented Chinese and other missions around the moon.
I talked to Scott for quite a while, and he had a lot of ideas for things I could start looking at. He has a bunch of info on his website, on Twitter, and on Blue Sky, and I'll put links to all of that down below in the description. If people are interested in zombie satellites, he has tons of info about different ones out there, how to get into the hobby, what the techniques are, what kind of equipment he uses, and he's got all kinds of great resources. I am just starting out with this topic. This is brand new to me, so I am going to try out some of the satellites that he's suggested, try listening to some of these zombie satellites. And I am learning this topic right as I film it, so hopefully it makes some kind of sense when the video is all put together, but we'll see what happens. So we're going to try starting with a relatively easy one of the Transit 5 series. These were an early kind of pre-GPS navigation system, kind of a test platform for military navigation. And some of these satellites are still operating in some way or another, not completely functional, but they do still send down some data.
It's one of the oldest objects in Earth orbit. It's got a catalog number of 965. It's 1964-083 Delta. So it's actually got a bit of nuclear material in it. So it even makes it more interesting. Every once in a while, pretty much every orbit, it sparks up and has a very loud and very musical signal. Its telemetry has been studied a little bit because it still sends nonsensical telemetry. Some old school work has been done on it to study the telemetry from a satellite from 1964. So here's actual data that they've copied from it, and he's explaining his work. So it's kind of a neat thing. So if somebody's interested in that, we can go back and look at how a satellite from 1964 sent its telemetry to Earth. There's a guy in Australia named Mike McKenney who provides a pretty good reference to 137 objects, mostly zombie satellites, but he does keep track of some of the more later stuff that is in the band. So if one of your audience members may want to look there, this would be a really good reference for them.
I'm going to use the relatively simple QFH antenna, the quadrifilar helix. We built this years ago to listen to NOAA satellites and NOAA weather satellites like number 15, 18, and 19, and those transmit on 137 megahertz, the VHF band. This is a relatively simple antenna to build. I am not an antenna expert, so it took me a couple tries to get this right, but it's pretty good for 137 megahertz. That's what this transit satellite is using. That's what it's still transmitting on, so we're going to see if we can hear it. I'm using a program called PuTTY. That is just a communications terminal program, and I'm connecting to my Raspberry Pi up on the roof with remote login. Then I'm running this script, which is RTL_TCP. That's the program to stream the data from the RTL SDR, the software-defined radio that's plugged into the Pi. The arguments are -A and then the IP address of the Pi. So that basically connects to the RTL SDR, starts streaming it over TCP. So next I open up SDR++ here on my local computer. For the source, I want RTL TCP, I want the IP address and the port, and those are the same as what's over here. So we've got port 1234. We're going to start this just like we would start a local RTL SDR hooked up to this computer. And yeah, there we have our radio spectrum centered around 137.65. I have a lot of noise on here. It's not looking great at the moment. I don't remember this much noise before, and we're going to zoom into the frequency of interest for transit 5, and I think that is around 136.65. And once again, my lack of planning has screwed me up. I figured, oh, transit's coming over in 15 minutes. We'll get this all set up. We'll get a nice shot of me on the computer. Well, then the leg fell off of my tripod. This is a brand new tripod. So I'm just hand holding the shot like an idiot. So technically, I think this is the center carrier of the transit satellite. There are some sidebands of data. This data is mixed in with all this noise. But we've got some sidebands, we've got some echoes and whatnot. So it's basically a straight overhead pass. So these are ideal conditions for receiving this satellite.
That's the sounds of a satellite from 1964. And that's that telemetry we were talking about. And I believe all this is gibberish. It's not really sending really meaningful stuff anymore, but it's the telemetry system's still working, and obviously the transmitter's still working. And you can see it's got a pretty respectable signal. Another interesting thing about this kind of satellite archaeology, if you will, is that when you look at the signals, you get a sense of historically what the different space missions, space agencies and stuff like that were using for modulation. You may not get any direct information from the telemetry itself, but what you get from it is, oh wow, they're still using some of this stuff today.
And I can really see the dramatic Doppler effect as this passes overhead. The center frequency here is drifting to the left at a noticeable rate.
This is a really important aspect of identifying satellites, is comparing the Doppler to actual TLEs for the satellite, so you can confirm what you're listening to. So as you can see, there's a whole bunch of stuff that I've done related to the transit satellite. That's what you'll find on my Twitter feed. Is if I did a lot of work on the topic, you'll find all kinds of things, and you can see how I identify a satellite. If your viewers are interested, I generally always use the official names in capital letters as the Space Command issues the TLEs. I always provide the NORAD ID, and I always provide the COSPAR ID, which is the UN kind of way of referring to a satellite.
Well, I just went on a 2-day side quest trying to reduce the radio frequency interference on my 137 megahertz setup. We'll have to figure that out another time. I've got some new equipment ordered, but I think for now I'm going to have to move on to some other frequency.
So moving up, the next big satellite band is 236 to 237 megahertz band. And there was a bunch of really interesting and really old missions that used this band. And particularly of interest in 1967, LES-5. And here's LES-5. I've actually optically observed it with my telescope. And you can see it drifting through the geobelt. It's in a slightly lower orbit than geostationary altitude, so it drifts from west to east through the sky and drifts around the world. And it was intentionally placed in that orbit to test UHF communications. And here I discuss how we started to hack the satellite, get into figuring out what all these unknown telemetry channels were, and relate them to things that we were finding in old papers from the 1960s that discussed the satellite, the experiment, and the results of it. This is the kind of stuff you can do with old zombie satellites. You can actually, kind of kick the tires. And a lot of times all of this literature was published long after they thought the satellite was either dead or disconnected. So they're not being too guarded about it anymore, not thinking that someday it might turn back on. You did a couple of recent posts on all the pirate activity that goes into the SATCOM UHF band. Yeah, there's a zombie there too. Here's a recovery image of that. It's a pretty loud object. It's around 258 megahertz, 258.5 megahertz. OV3 bus. It's a weird hexagonal thing. This particular OV33 was mapping particle radiation in space and all kinds of stuff up there.
Let's try another one that Scott mentioned in the UHF band. It might actually be easier to see here from Minnesota if we aim this MilSat SatCom antenna. This thing is on loan from a viewer. It's one of my favorite antennas, mostly because it does this. Now, when I used this on the channel before, I got a bunch of military veterans and some active duty military personnel who have actually used these, and I got some suggestions for how to use it. For example, I think I didn't have my ground plane pulled out all the way before. Yeah, that seems to be as far as it goes for this model. Maybe there's another model of these. I think several companies made antennas like this for the military. And this beacon frequency that happens to be kind of mixed into Air Force SATCOM comm frequencies was not necessarily for voice communication or ground-based radio communication. It's just a tracking beacon. I've gone ahead and moved the SATCOM antenna up onto the garage roof. I took off the director elements on the top, and this makes it much less directional. So now it's picking up all kinds of stuff from all over the place, and I've got it just aimed straight up because this is an overhead pass of a satellite, not a geostationary satellite. Of course, it's terrible to see the screen here in the daylight, but we are getting signals from the FleetSatCom series, even with the antenna aimed up in the sky instead of at geostationary orbit. So that's a pretty good antenna. I think this is going to look like absolutely nothing on the laptop screen with the sun behind me, and I don't have a screen recorder on this laptop, so I'll probably just record a baseband and I'll throw that up as an overlay here on the video while I babble away over the top of it. Well, the satellite should be right overhead right now, and I'm basically seeing nothing except I've got a transponder on 258.65 that's regular FleetSatCom, but nothing on the frequency we're looking at, nothing a little higher or lower than that with Doppler. I'm actually going to pop these director elements back on and aim the antenna where I think the satellite is, just to get the best chance of hearing anything from it. Yeah, here's something. I've got a very, very faint signal just below 258.5 megahertz, which makes sense because the satellite has now passed over and the frequency will be decreasing due to Doppler shift. So I think I am seeing it. It is just incredibly faint. It is just a very, very faint carrier signal. And this is that beacon frequency. I can try some of the other frequencies that were supposedly used for telemetry. Yeah, nothing identifiable. So all we have is that very, very faint beacon on 258.5 megahertz.
In the 100 or 366 megahertz region, I have found Chinese satellites, contemporary ones. So that's another region of the spectrum that does have satellite activity. So if you're into exploring that region, it's a relatively unexplored area. Interesting ways that you can really learn about the history of space is by observing and actually identifying the satellites that pass through your field of view. And if you do that long enough, you start to find all these weird missions that you'd never heard of, and you Google and you're like, oh, that's really interesting. And then you go down these little rabbit holes of reading all about them. Heading up to the amateur band, 435 megahertz or so, there are zombies there. That is an active satellite band, not just for amateurs, unfortunately. The commercial guys muscle their way in from time to time. But there are some zombie satellites that hang out there. Here's POSAT. I believe this was Portugal's first satellite, and it was reported dead, and it doesn't look too healthy, but it was certainly emitting a signal. So there you go. That's totally this is even ghetto for Save It for Parts.
Yeah. Oh, you gotta have the burn barrel in there.
Yeah, that's the burn barrel, and had a dish antenna, and I took that Yagi antenna and pulled off a few elements so I could feed the dish. And this was in an attempt, because we had this super strong carrier that we're seeing, and we couldn't figure out what the heck it was. And so I needed to pinpoint the spacecraft more. So I needed a dish. So this is your 990 megahertz tracking dish, quote unquote. My first attempt, and boom! Now we were seeing something. And what we found here was retransmitted, looked like cellular transmissions. So what it turned out to be is a yet unknown transponder from the Russian military. on these spacecraft that we thought had ceased operations in the 2000s when the Molina satellites ended. The system was actually used by the Russians to communicate with their strategic rocket forces. In other words, this was their transponder that all these mobile nuclear rocket launcher systems that the Russians have would use to intercommunicate. This is kind of a ground terminal that they would use. Up on L-band, we have this guy here, NOAA 2. A lot of these old zombie satellites, they may not transmit continuously for whatever reason. They may be rotating or tumbling or something like that. So this is kind of like over time, you know, like NOAA A, it gives you a really strong signal for a few seconds and fades out completely and then comes back. And
okay, antenna is working and tracking, and we are occasionally getting a signal. Again, this is just an intermittent signal because the satellite is tumbling, so it's only going to work when it gets sunlight on the solar panels in the right angle. There it is. That is NOAA 2 transmitting on L-band HRPT. I really need a permanently mounted L-band tracking antenna. This one can't be left outside because it's basically just naked electronics. There's no radome cover over it. And with the helicone antenna on here, I can't put the original radome back on this, so I'll need something else. Or I need something like the S-band tracking antenna that's over here. I definitely need to improve my tracking setup, and that's kind of an ongoing struggle, as I'm always too busy doing active projects like this to do the big long-term maintenance projects that I would need to do to make everything a little bit easier. All right, so the next pass is NOAA 9. This is another dead NOAA satellite, but I think it's only transmitting a carrier signal. There's no modulation, there's no data coming down on this one like there's the NOAA 2. Okay, so yeah, nothing on L-band. Let's switch gears really quick and we'll actually try the APT signal, the VHF 136 megahertz. This one is at 136.62. It was originally 136.77, but I think it's had some signal drift or radio wear and tear over time, basically. I'll leave the helicone here running just so I can visualize where the satellite is, but I probably won't be moving the V-dipole much. And boy, I am getting a lot of interference from the laptop and from this thing here. Just having the antenna close to all these electronics running is not helping things. Yeah, I'm getting nothing but noise on the laptop. I'm just too close to my own equipment. All right, so I kind of screwed up that last pass, both forgetting which frequency I was looking at and then trying to use a V-dipole right next to a noisy computer. So yeah, those were amateur mistakes, but I'm an amateur. I still struggle to remember all the details that go into capturing a satellite pass, the frequency, the timing, the equipment to use. If you're starting out in the SDR hobby, in the satellite hobby, and you feel dumb, well, that's just fine, because I feel dumb plenty of times.
Now, S-band is probably the best place to find zombies. There's lots of them. There's really loud ones up and down the band. So if you're going to search for zombie satellites, this is a good place. There's lots of people searching there and monitoring continuously. So, but generally speaking, some of the best ones are a little bit further from Earth, as we'll see here. You might have heard of NASA's image. I recovered that.
Yeah.
That was kind of the first really, well-known zombie satellite that kind of caught the world's attention. That's the link here. So if any of your viewers haven't followed this story, it generally articulates the techniques used for finding a zombie satellite, software and stuff like that. So if you look at the links and on our Riddles in the Sky website, we've given some information about how to do that. Here's Polar, which is on a similar mission to Image.
All right, I'd like to try another one that Scott recommended. This is the Polar Plasma Laboratory, launched in 1996. So to get this one, we're going to have to fire up the S-band dish. This is the Winegard Traveler. It's a modified RV satellite dish for TV. And I've written a couple scripts to interface with this dish and basically make it do stuff it's never intended to do. Everything around here is made out of spare parts, so it doesn't always work the first time. Let's try running that rotor control script again. All right, we're connected to the dish up on the roof, so now I'm going to open up gpredict and use that to tell the antenna where to point. It does seem to know where Polar is, so we're going to go to antenna control, tell it to look at Polar, and yeah, you can see on here that is a weird orbital trajectory. At least when compared to any other orbit that I've looked at in the past, this one is just bizarre. Fortunately, the track of the orbit is fairly close to me. This is a higher orbit, so even though the satellite itself is somewhere over Alaska, it's high enough in altitude that I can still see it here from Minnesota. So while it's doing that, we'll pull up STR++, start listening to the radio frequency this is supposed to be on. Now it's supposed to be at 2.265 gigahertz, and we are getting a signal right there. Let's just verify if that is the polar satellite. I'm going to tell the dish here to slew away from it and go look somewhere else. So if this is polar, as soon as the dish starts moving, we will lose that signal, and yep, we did. Looks like the dish is coming back into lock. Signal came up again, so yeah, there we go. That's the signal that we're looking for on S-band from the polar zombie satellite. It's not super exciting, it's just a carrier. This is just the telemetry carrier signal. I don't think there's any data happening here, and one interesting thing that we can actually see here is there are some little gaps. I think that's where the satellite is rotating. So as it rotates, the antenna is pointed towards Earth and then away from Earth. So we're getting higher and lower signals as the satellite spins around up there. I can show you what that actually sounds like. It's just going to be kind of a whistling noise. This S-band antenna is working pretty well, and I've got some pretty good filters and amplifiers on it, so it's not getting some of the radio interference that we were getting on other bands recently. So another one Scott mentioned is this image satellite. This was one that NASA thought was dead for quite a while until Scott proved that it was still actually sending down some data. I'm not sure if it's usable data, but it's doing something. Let's see if we can find it. Now, this one is not in gPredict's catalog of TLEs, and I'm not quite sure what category it's under, so I'm actually going to just manually add it here. We've got the TLE data from Into.io, so if I just copy this and dump it into a text file, then I can go back over to gPredict and we can update from local files. I don't know if this one is still transmitting or if it's going to be strong enough for me to see. I think after Scott found it, NASA did try to get back in contact with the satellite, but they had some issues with it and they said that the signal kind of comes and goes, so we might not see anything from it here. And it kind of looks like that's the case. I'm really seeing nothing on the radio spectrum. I would actually like to know about more S-band satellites that I could look at with this dish, because there aren't really that many active ones. There's the NOAA series, of which we've just lost NOAA 18, sadly. Maybe that will become a zombie satellite someday. We can only hope that it turns into a zombie like NOAA 2. But there's also the DMSP satellite series. Those are the military version of the NOAA satellites that send down kind of live, real-time images of weather conditions on the Earth's surface. And I did actually try my own little hunt for zombies in the DMSP catalog. I went through every DMSP satellite that had been launched and that is still in orbit, tried to listen to those when there were good passes over my location here. Unfortunately, I didn't find any DMSP zombies. Unfortunately, I also don't have any video of that because it is kind of boring. It was just me sitting at a computer, running the antenna, hearing nothing, repeat a dozen times for a dozen different satellites. So that makes for terrible video. It also means this video is taking longer and longer to finish because I keep getting distracted by stuff like that. Circling back to NOAA 2, I did try to decode the signals coming down on L-band that I recorded earlier. And this is a little bit of a tricky process. Even though it's L-band, where you usually get HRPT signals, the high rate picture transmission, the actual encoding, the format that's coming down from NOAA 2, since it's so old, is closer to APT, or automatic picture transmission, and there are some decoders for this available online. I fired up GNU Radio. This is a open source radio project that you can kind of plug in different modules. You can basically write your own encoders, all kinds of basic radio stuff in a very flowchart oriented process that works with various SDRs. This was kind of one of the first modules I played around with. Didn't really get much out of it. Okay, we're back with GNU Radio Companion. I talked to Derek SGC and he suggested a different decoder for NOAA 2. So this flowchart for GNU Radio is originally from Zerbo of zerbo.net. I'll put some links to him down in the description if anybody's interested. I'm reading through the blog right now to see if there are any instructions on exactly how to use this. He also said to make sure my input blocks are set for 16-bit. All right, so I'm trying a little bit of software save it for parts. I went over to the other decoder. I grabbed this block, which is called throttle, copied that, and pasted it over here in the supposedly better flowchart. Well, it looks like we're getting something this time. We have slightly darker static than the default static. All right, I'm gonna try NOAA 2 one more time with the medium-sized L-band dish. Now this is one I've showed in a couple other videos. It's a little bit bigger than the helicone antenna. It's made out of an old wireless networking dish with some cookie can lids and other nonsense, but it's been a pretty reliable one. So the helicone has been having just ongoing issues, so we're gonna give this one a shot. All right, we've started tracking. It's always hard to tell at first because there's basically very little movement until the satellite gets a little bit higher above the horizon. This one will go down almost to 0 degrees elevation, which is nice. The helicone only goes down to about 15 or 20 degrees, so this is a little bit more capable dish. It's running on a security camera pan tilt mount, and I've really been enjoying it. If anybody's interested in how I built this, I'll throw a link down in the description about it, and it's just running some open source software from a school group in Australia, actually, that came up with the software to drive this, so it's not terribly complicated. I know I'm babbling a little bit here, but I am pretty excited to see something that is somewhat more recognizable than just an empty carrier signal. That's mostly what we've been seeing in this video, is empty carriers from dead satellites. They're not modulated in any way. They're not sending down any data. NOAA 2 is sending down a little bit of data, even if it's not a pretty picture of the ground, even if it's not really usable data or super interesting data, it's still more interesting than most of the other stuff we've seen so far. All right, now that is NOAA 2, and that is a beautiful signal. We are getting a really nice capture with it now. I hope we're going to be able to do something with this to put this through the GNU radio pipeline and at least get some calibration bars out of it, if not any imagery. But yeah, that's a really nice signal, and it's finally looking good here. And we're basically at the peak of the pass, so this is ideal condition. The satellite is essentially directly overhead, and it is getting solar power. It is rotated enough so that it is hitting the sun. Well, I spoke too soon. The satellite just lost its sun orientation and the radio shut down. So now we have to wait a couple more minutes until it turns on again. So coincidentally, we also have NOAA 9 passing overhead, basically directly overhead right now, just as NOAA 2 left. I'm looking at kind of the whole L-band area where those NOAA satellites operate and not seeing anything from NOAA 9, which I guess is to be expected. It's only supposed to be on 137 megahertz, but I figured while we have the dish out here, we might as well try it. But as usual, we're just getting some kind of interference. Just for comparison, here is NOAA 15 on L-band. It's pretty weak. This is not a zombie satellite, but NOAA 15 does have an issue with its L-band transmitter, so it's really difficult to get much on here. I still have all of my gains cranked all the way up. I have the bias T on, I have the LNA going, and honestly, the signal from NOAA 15 is about the same, if not worse, than it was from NOAA 2. So yeah, this one is pretty challenging on L-band. It's much better on S-band, and then it's decent on VHF. All right, so we're trying to run the NOAA 2 decoder pipeline on GNU radio on that last recording that I got for NOAA 2. There we go. We finally have a calibration ramp from NOAA 2. So this is similar to the calibration bars that you get on APT on the sides of your image from the other NOAA satellites. If I zoom out here, all we're getting is that calibration ramp, so we're not getting any imagery from the ground. So these calibration lines are still a little bit mysterious to me, but reading through some of the old manuals and documentation online, they're essentially related to the temperature and voltage of each sensor. So it's a calibration method for users on the ground to be able to correct the image based on the sensor temperature. If you're interested in reading more about that, I will link to some of the original documentation I found. It's a little bit beyond me, but it's possibly interesting, especially since this is the only data that this sends down anymore, is the calibration data about the actual sensors. All right, well, this one has been a lot of fun. I know it's been a longer video, so to all the people who stuck through and watched the entire thing, even if you watched it at 2x speed, thank you for sticking with it. And we have tons more material from Scott Tilley. I had so much information that I was not able to include in this video. We've got more stuff we could look at in the future. If people like this topic, if they enjoy the idea of looking for zombie satellites, there are a lot more that I could look for. Some of them are in different orbits that I couldn't see at the moment. Some of them need different equipment that I don't have set up. And then I had some ongoing issues with the equipment that I do have, which hopefully will get fixed in the near future. And this video was actually Scott's idea. He contacted me and said this might be something fun to do. So a big thank you to Scott for taking the time to talk with me, for giving me so much information, so many pointers on how to get into this branch of the satellite hobby. This is really cool, and I'm really enjoying it, and it is something that I plan to look at more in the future. I know it's maybe not the most flashy or exciting, it's not downloading military data from government satellites, but there are some military satellites out there in the zombie category that maybe we can look at in the future, so that could be something fun for a follow-up. Again, if this is something you're interested in, check out Scott's links down below in the description. He's got tons and tons of info on his website, on various social media, and just all kinds of cool resources for getting into this. Let me know down in the comments if you enjoyed this video, if you want to see more longer videos like this one, or if you'd rather I stick with stuff that's 15 to 20 minutes. That's always good feedback. As usual, big thanks to my Patreon supporters who help make videos like this possible. They really help out with me being able to afford satellite equipment, filming equipment, and just being able to take the time to experiment with new topics and learn new knowledge. If you'd like to help support this channel and more content like this, I will have the link to Patreon down below in the description, and my Patreon supporters get to see the videos a week early, so that's always a fun benefit. Finally, thank you to everyone out there for watching, and we'll see you next time.